Hello everyone, my name is Tamina and this video is about linear independent vectors. And I have here a definition. It is really simple. If we have a set of vectors like v1 to vn, and if we want to consider if they are linearly dependent or independent, we should try this equation. And if this equation is true only for a1 to an equal to 0, then v1 to vn are linearly independent. And it means that none of these vectors, none of vector v1 to vn can be eliminated. And if we eliminate and reduce one of these vector, actually we eliminate one of our answer. The actually independent vectors are important for solving systems. For example, for optimization problem, we need to solve a system, and sometimes our system is include of linear equation. And this equation we have several vectors, and we should try to solve these systems. And one important thing in this methods and ways is that these vectors should be linearly independent in order to able us to solve these problems. So we need to solve this equation and find the value of a1 to an to make sure that we want to vn are linearly independent. It means that if we want to vn are not dependent, we cannot write a vector from this set as a linear combination of other vectors. There is no relationship between this vector at all. I have here several examples or several features of this kind of vector. If we put our set of vector like we want to vn in a matrix, it means that vector v1 as first column, v2 as second column, and so on. And we want to consider if our vectors are dependent or not. We can define that these vectors are independent if and only if every column is pivot column. And for pivot column, I want to refer you to two other videos. They are not from me, but from other persons. But they are really good in this definition and concept. And so, if you are interested in meaning of pivot column, you can watch these two videos. Another way to explain this sentence here is that if we put our some vectors in a matrix and solve these linear equations, a dependent vector will have infinite solution, but independent vector will only have one solution. It means that if we have independent solution, we can solve our system, and all value of variables will be finite and single value. Another feature is here that a set of vectors are dependent if there are more columns than rows when we put these vectors in a matrix. I have in the next slide several examples of this matrix. And another way to explain about this feature is that if we are in, for example, two-dimensional vector space, if we have more than two vector, one of them is dependent vector. For example, here in this matrix, the first column or first vector has a relationship with third column. It means if we multiple first column in minus zero 0.5, we will get third column. And it means that this matrix will not give us single value and exact value for each variable, and one of our variable will have infinite value. And here in this matrix we have 3 row and 4 column, and the number of column are more than a number of row, and so one of these vectors is dependent, and so the set of these vectors are not linearly independent. And the other two examples we are here in R2 and R3 space, and so the number of column are more than the dimension of space, and so um, one of them is dependent to others. In the next slide, I have examples of a direction of vectors. If the direction of two vectors like v1 and v2 is completely different and completely opposite. It means that they have a 180-degree difference. So we can easily find a non-zero a1 and a2 and make this clear that these two vectors are not dependent. In the next example, we have two vectors and they have completely different direction, not a 180-degree difference, but they have completely different direction, and so these two vectors are also not dependent. In the last example, we can put our vectors in a matrix. It means that first vector in first column, second one in second column, and so on. And we can call this matrix C and try to solve this system Cx equal to 0. If um, at least one value in a vector x, x1 to xn, according to vector v1 to vn, one of these xi is not 0. It means that a set of vectors v1 to vn are not linearly independent. In this video, I will shortly explain about linearly independence vectors and the definition in this direction. If you have any question, please write me in the comment. And if you find this video helpful and interesting, please subscribe to my channel because I have several videos in machine learning and all mathematics, statistics, and so on. Thank you. Bye.